Welcome everyone. Welcome to Newton Gate Academy where we make your dreams come true. This is Saptarshi Dotto and I am a physics faculty here. Today we are going to study, or should I say we are going to discuss some of the key concepts of vectors which is of class 11 level. So let us begin. So in the first question of the day, the question says that under which condition mod of A plus B vectors is equals to mod of A vector plus mod of B vector holds good. So let us see under which condition does this condition holds good. So for any two vectors, if I write it like this, or should I say if I draw it like this, then this is, let this be A vector and let this be B vector, and theta is the angle between these two vectors. Now, what is the formula for the resultant of these two vectors, that is A vector and B vector? It is given by something like this: A vector plus B vector, which is equals to A vector dot A vector plus B vector dot B vector plus 2A vector dot B vector. So this is the vector representation of the resultant of these two vectors. Now we have to find out the mod of the resultant. So let us try to find out that. So what is the mod of this resultant vector? The resultant vector's mod will be something like this. It will be something like this. So now let us consider under which condition this holds good. Let us see. Now suppose this A and this is B, and this is A square and this is B square. Now only option with us is that if this cos theta is somewhat, that is if I can write that theta equals to 90 degree, then what will happen? Then cos theta will be 0 and this whole part will be 0, and we will be left with this A square plus B square, and it will not result into this. So our this option is cancelled out. Now let us try a different value of theta. Let us suppose theta equals to 0 degree. So for theta equals to 0 degree, we know cos 0 degree equals to 1. So we know cos 0 degree equals to 1. Now for this theta value, that is for theta equals to 0 value, this cos theta will be equals to 1, and we are left with something like this. We are left with A square plus B square plus 2AB. And now this is a standard formula. Standard formula gives A plus B whole square. So this eventually becomes A plus B. Now under this condition, can I write this? That this is our A vector plus B vector whose mod is this is equals to this. So the required condition, or this required condition, is that theta equals to 0 degree. Now if theta equals to 0 degree, then this equation holds good. That is our this condition holds good. Okay, so based on our previous analysis, can you find me the answer to this question, that is under which condition A minus B mod will be equal to mod of A minus mod of B? Holds good. Now, please find the solution of this question and comment in the comment box your answer. Now, our next question is that if sum and differences between two vectors are equal in magnitude, which is this a plus b mod equals to a minus b mod, what conclusion can be drawn from this? So let us see. Now, since they have given mod of a plus b and mod of a minus b, we shall approach it from there only. So let us write the respective expressions for a plus b and a minus b. So our a plus b is something like this. It is a square plus b square plus 2ab cos theta. And what about our a minus b? So a minus b is basically this, a square root of a square plus b square plus, or should I say, this is minus here, minus 2ab cos theta. So these are the respective expressions for a plus b and a minus b. Now we have to find out under which condition this holds good, or should I say what conclusion can be drawn from these two vectors. Now suppose this is a plus b and this is a minus b. So under which condition these two will be equal? See here 2ab, or should I say twice ab cos theta is being added to this quantity, and here the same quantity, that is twice of ab, is being subtracted from the same quantity. So in order to make these two similar, we must get rid of this term, that is we must get rid of these terms in both the expressions. And since neither of the vectors a vector and b vector is a null vector or a zero vector, so we are only left with the option of cos theta, that is cos theta being 0. And for cos theta to be 0, theta must be pi by 2, right? So theta must be pi by 2. So for this value of theta, this term as well as this term cancels out, and we are only left with this part. And now can I write from this expression, that is a vector plus b vector mod, which is equals to a vector minus b vector. Can I write this? And this is the condition, or should I say the required condition. And to arrive to this required condition, what we need? We need cos theta to be 0 or theta to be pi by 2, that is 90 degree, and that means these two vectors, that is a vector and b vector, this is our a vector and this is our b vector, then both of them are perpendicular to each other, that is, it is something like this, and the angle between them is 90 degree, which is a right angle. Now our next question is, determine the vector joining the 2 points A whose coordinates are given by 2, 3, 0 and another point B whose coordinates are given by -1, -2 and -4, and which is directed from A to B. So we need to find out this vector. So how to find out this? Let us find out. Now to find out the solution to this question, let us draw the 2 points in the coordinate system and try to draw the respective position vectors of these 2 points. So let us try to draw it. Now this is our standard 3-dimensional system. Now this is our x-axis, this is our y-axis, and this is our z-axis. I am considering this only. Now the point A is somewhere like here. Let us suppose point A is somewhere here and point B is somewhere here. This is our point B. So what are the respective position vectors of A and B? Let us find out. So this is the origin. So if I draw the position vector of this point A, then it will be something like this, and that for B will be something like this. Now we have to find out the vectors joining these 2 points, that is this vector, and the direction should be from A to B, that is it should be in this direction only. So now our first approach is, let us write the expression for this position vector of A, and if I consider the position vector of A to be R1 and that of B to be R2, then the expression for R1 will be something like this. R1 will be 2I plus 3j plus 0k, and that for R2, this is a vector and this is also a vector, R2 will be minus I minus 2j and minus 4k. These are the respective expressions for the position vectors of the 2 points. Now we need to find out the vector, this AB vector. So from this picture, can you see that the triangle law of vector addition can be used here? Because see, this is a vector and this is another vector, and this R2 vector, this R2 vector is basically the resultant of these 2 vectors, right? So if I just write this vector as AB vector, then according to the triangle law of vector addition, can I write this, that R2 vector is basically equals to R1 vector plus RAB vector? Can I write this? Now after this, can I write RAB vector equals to R2 vector minus R1 vector? This is standard operation. Now we know the expression of R1 and we also know the expression of R2. So let us find the expression for RAB. So if I just write this RAB here, this is our R2. Let me just RAB. If this is vector, so this is basically R2. So let us write this R2. We have minus I minus 2j and minus 4k, and minus R1. Here we have minus R1. So R1 is this. So can I write minus 2I plus 3j, and this is 0, this part is 0. So this is the expression for R1, and from this let me just subtract the values. So here we have minus 1 with I and here we have minus 2 with I. So these two will basically form minus 3I. And here we have with j we have minus 2, and here with j we have minus 3. So can I write this as minus 5j? Can I write this? And after that we are only left with minus 4k. So this is the expression for RAB actually. This is the expression for RAB actually, and which is we are required to find out. So this is our required expression for the vector. So here we have our next question. The next question says that calculate the angle between these two vectors, that is A vector, this is A vector and this is B vector, and we are required to calculate the angle between these two. So how to calculate the angle? Let us find out. So before calculating this value, let us find out what could be the value between any two vectors. Now if I consider A to be any vector and B to be another vector, then A and dot B, that is the scalar product between these two vectors, will be something like this: mod of A vector mod of B vector into cos theta. This is standard vector multiplication, or should I say scalar multiplication between two vectors. Now from this expression can I write cos theta equals to A vector dot B vector divided by mod of A vector into mod of B vector. Can I write this? And after this, since if I can write this, then we need to find out the A dot B and the mod of these two vectors. So what is our A dot B then? Our A dot B is basically, if I write A dot B, then A dot B is this 3, this plus 4 and this plus 1. This is our A dot B, and mod of A is something like this. So this, if I just calculate this, then this is 8, and here we. Now if I can write mod of A equals to 1 square plus minus 2 square plus 3 square, and for mod of B can I write this is 3 square plus, again we have minus 2 square, and here we have 1 square. Can I write this? So the values of this will be basically root over 14, and from here also we shall get root over 14. So our expression for cos theta will be something like this. If I can just clean this part, then the expression for cos theta will be A dot B is 8, so I am writing it as 8, and this is root 14, root over 14 for one, and for the other also we have root over 14. So here also we have root over 14, and we get 8 by 14, which is basically, if I just cancel this and this, then we have 4 by 7. So theta, or if I write cos theta equals to 4 by 7, and since 4 by 7 is between minus 1 and plus 1, and cos theta is also between minus 1 and plus 1, so this answer is right. You can also verify your answer from this method also. So our next question is, why vectors cannot be added using ordinary algebra? So let us try to find out why is it so. Now for ordinary algebra, we use only scalar values, that is, we use something like 5, or we may use 7, or we may use 9, and we may use any scalar value. But in ordinary algebra, do we ever use any direction associated with these numbers? Well, the answer must be no, because we never do so. And that is the actual reason why vectors cannot be added using ordinary algebra, because ordinary algebra has scope for only scalar values, and since vectors are composed of scalar values as well as a direction also associated with the vector, and so for that direction only we must have some other methods to accompany, or should I say to calculate the direction part also, and hence vectors, or should I say the calculations of vectors must be done using a special kind of algebra, and that algebra is called vector algebra, using which vectors can be added or subtracted, or it can be multiplied, or it can be divided also, but vectors cannot be added using ordinary laws of algebra. And with this we have reached to the end of this video. Hope you find the video helpful, and if you did find the video helpful, then please hit the like button and also hit the subscribe button of the channel, and please share this video with your families and friends. Hope to see you in the next video. Goodbye.